Hope you had a good evening, good dance at the Ceilidh. Welcome to the Farm Practice Room. This room's hosted by Agricology, PFLA and the Soil Association. So welcome. Agricology is a community of researchers and farmers sharing knowledge on agroecological practices online and in the field. So many of the things you've been hearing about over the last couple of days, you can learn more on agricology from farmers and researchers. And one of those things we have on there is intercropping and companion cropping. I think it has huge potential in the UK. It's used a lot more in other parts of Europe and across the world. And so we're really lucky today to have some of the pioneers that are making that happen in the UK. We've got Adrian Newton, who's a plant pathologist from the James Hutton Institute, who's been working for a long time on crop diversity and has some trials going up in Scotland. We've got Charlotte Bickler from the Organic Research Centre. We work together on the IF, the Innovative Farmers Field Lab on intercropping. And we've got Andy Howard, who farms in Kent, and did his Nuffield on intercropping and companion cropping and is putting that learning into practice on his farm. But has been experimenting with different mixtures over the last few years. So I will hand over to them to share their experiences, and then we'll have time at the end for some questions. We'll also be going in for a breakout session after this on crop diversity with people from the IPM session as well. We've got some live beneficial insects, so do join us for that bit as well. But I'll hand over to Adrian.
Thank you. Right, I'll now try and remember what was on my first slide. The title. So I'm going to be talking a bit about some of the principles of why we use diversity. In a way, it's a bit like probably preaching to the choir here. But this is a lot of it's based on the Diversify project, though I'll be looking at some of the work that led up to that. That's just the team up at Hutton who worked with me on this. And this work is largely field trial-based work. Some of it's including on some farms, apart from our own trial site there. But what I'm going to basically be talking about is some of the principles behind diversity. And diversity isn't just diversity, it's complexity and heterogeneity as well. And there are important qualities of actually delivering diversity and the benefits in practice. I'll just say a bit about that, about what the traits are we try and use in diversity. In other words, which are complementary, or to ecologists, that be competition and facilitation. Resource. Oh, it's gone blank. It should say over-yielding there, which is resource use efficiency. So I'm going to say a little bit about that and some practical examples. I think somebody's pulled a plug somewhere. And then that's really all different components of integrated pest management. This is where I really can't remember what my next slide was. Nope, I can't remember what it was. Oh yes, it's the principles of the actual component numbers that we use in mixtures. I'm going to illustrate this largely, here we are again, from actually, rather than intercropping with different species, some work done with variety mixtures. So, the point I hadn't made there is really about managing interactions not just between plants, but between plants and microbes and microbes and microbes, and it's above and below ground. It's about optimizing those interactions. So, show you some graphs. These are graphs that I use quite a lot when talking about the principle of using diversity. And these are winter barley mixtures. And what you got here is 2, 3, 4, 5, and 6 component mixtures of winter barley, and this is how much they reduce disease compared to the average of them grown as monocultures separately. So in other words, with 6 component mixtures, you're getting about a 50% reduction in disease. That's a function of the complexity. It comes through in yield, which is the green bars at the bottom, but even if you use fungicide in this case, you still get positive interactions compared to the mean of the components. So you get benefits from these interactions. On the right is a good Scottish example. It's spirit yield from spring barley varieties. There's 3 old varieties of barley here, Chalice, Chariot, Prisma, 3 different sites, and here's a mixture of the 3 together. And you'll see that on individual sites, individual varieties do poorly, and there's no consistency there. But the mixture does well across all sites, and it does at least as well, if not better, than the best of the component varieties. And that, again, is a feature of using diversity, is stability across sites. Another one is not just complexity, but heterogeneity. And here's just a simple example done on a sort of field scale of about 200 metre long plots by 3 metre done with a farm drill. And what we've got here is winter barley varieties which were mixed. And 2 in particular, in white are the monocultures, the yellow in the mixture. We did 4 different mixtures. I'll just talk about 2 of them. One is what I've called premix, which is a homogeneous mixture of all 3 components. The other one, in situ, is where you put the varieties, variety 1, then variety 2, then variety 3 in the hopper, in the drill, and then you jump into the drill with a shovel and churn it up. So you get a very crude, patchy mixture. When it comes to the yield, the in situ ones gave a really good 13-17% increase in yield. The ones which were pre-mixed in this case didn't give any significant increase in yield. And the same thing came through in the amount of disease control. There's much more disease control when you had this patchiness than you get in terms of when they're homogeneously mixed. So it's not just diversity, it's complexity, and it's heterogeneity, which are all features of how the diversity may work best in practice in the field. The other thing is, what type of thing are we mixing? How do we actually choose our components to mix together? Again, I'm sticking with just barley at this stage. And here we've got a tall variety barley. It's an erectoid type, which includes the dwarfing mutation present in most modern commercial barleys. That's the other dwarfing mutation present in some commercial barleys, the semi-prostrate type. And there you can't see it because it's so small and pathetic, but it's a double dwarf one there. If you mix these together, and for example, again, this is compared to the monocultures grown separately, they're all positive. They all give yield advantage. Here, for example, the tall and semi-prostrate giving, about 8% increase. Here's the mean of this group, giving, about 5% increase in yield. 2 component mixtures, 3 component mixtures, again, giving yet more benefit. 4 component mixtures giving more benefit. So again, choosing things which are likely to complement each other. So different height or canopy types are likely to intercept light and things like that better at different stages, so you get better resource use efficiency again. Excuse me. Now I want to just move on to what we call over-yielding or increased resource use efficiency is what it comes down to. This is actually a picture of a winter barley crop for biomass. That's winter peas with rye and barley, I think, in there as well. Produce a huge amount of biomass. This is actually some data from when we first did this. These are the top 2 lines are from one site, the bottom 2 lines from another site, but lower of each pair is a half-rate nitrogen, and the upper one is a full-rate nitrogen. And where you've got peas in the mixture, here, at the lower rate of nitrogen, that's when you get the kick-in of the over-yielding effect. It doesn't really work so much if you're giving enough nitrogen anyway, and probably the legume component doesn't work very well. So that's the sort of over-yielding we get, and we got much response to the high yield potential as we did as the low yield potential. Here, look, moving on to spring crops. This is some work done on the Diversify project, where we've got a mixture of spring barley and peas. And these are the different varieties down of peas here, and different varieties of barley. And you'll see the ones highlighted in green are the ones which are between 20 and 30% over yielding. And you'll see that actually they're all with the varieties Ingrid or Daytona, and the other 2 don't work as well. They're still positive, but nowhere near as good. So there's a lot of choice of varieties of what actually works together. Again, which traits are actually working together here, and we've been measuring all the traits to work out which component it is of these varieties, or which characteristic of these varieties are the ones that says, yes, use that with this other variety. In this case, the variety of barley doesn't make too much difference. In the case of spring wheat and bean, here the wheat variety, Tybalt, did a lot better than Alderon. So in this case, it didn't matter so much which bean, but it did matter which wheat variety we used. So that was for biomass, that particular one as well. So again, you have to choose which ones, and that's what we're trying to do in the Diversify project, which you'll hear more about in a minute, to find out what's the best for any given situation to get good resource use efficiency. Finally, I want to just say something about microbial diversity. And here, it's not an example where, although this year we're using mixtures in this system as well, this is just monocultures we've used here, but it's looking at the comparison between a ploughed system and a direct drill system, because that makes a big difference to what happens to the microbiology of the soil and how that interacts with the crop. And that's important we manage that as well. And this is a whole load of varieties of wheat here. And what we've got is, in red, a ploughed system. This is in classical trial design, where we ploughed up one of the parts of the field. The rest of it had been 17 years in direct drill. And you'll see that with the direct drill, where you've got mature microbiology there, complexity there, and diversity. And in ploughed, we basically disrupted a lot of this in the mycelial networks, and so mycorrhizae and things like that weren't established very well. And you'll see it made a huge difference to the amount of yellow rust. In blue is the direct drilled, so the diverse system still, and it's made itself much more resilient to pathogen attack. This didn't just happen on this site, it happened on other sites as well. It happened for barley too, and it happened against powdery mildew as well as for yellow rust. So again, managing the soil component, and that is an important part of what you're doing in the interactions between these, and an important part of what we're doing. Finally, I just make the comment that this is really integrated pest management, or components of integrated pest management. And the use of plant-plant interactions, plant microbe interactions, and optimizing all these is a very important part of what we're trying to do in IPM. In many areas of farming, it isn't even a component which is considered much, but it is an important component, one of the tools, or several of the tools that we've got for implementing IPM much more effectively.